This year, iGEM Team Colombia has been hard at work developing a biosensor for the human bacterial pathogen, Vibrio cholerae. Our idea focuses on creating an easy-to-use kit capable of detecting this bacterium in different contexts, such as different kinds of food or water, by giving a simple visible color sign as a positive result. This kit would be useful for anyone who wants to detect cholera-infected food and water without having to use the expensive or tedious methods now available, such as immunogenic techniques or direct isolation and culture of bacteria. Possible users are companies in the food industry and quality or research labs. What is cholera? Cholera has been a scourge to civilizations the world over since ancient times. According to the World Health Organization's estimates, there are 3 million to 5 million cholera cases and 100,000 to 120,000 deaths every year worldwide. Caused by the bacterial pathogen Vibrio cholerae, the disease has been responsible for 7 global pandemics in recorded history, plus countless localized outbreaks. These outbreaks are triggered by V. cholerae when present in water sources or food, even at very small cell densities, and can have devastating effects, with mortality rates reaching up to an alarming 50% and causing death in a matter of hours if left untreated. The disease is most prevalent in low-income populations with inadequate health services and water management infrastructure. Although there is no official report about confirmed cases in Colombia, due to the weak report system, some of the greatest risk factors are widespread across the country's rural and even urban areas. Proof of this vulnerability is the impact generated by the arrival of the deadly L. tor V. cholerae strain in 1991, which caused 30,000 cholera cases in 2 years. Due to the disease's alarming quick onset upon infection and the fact that rapid access to medical care is often not available in affected areas, prevention is a key factor in combating cholera. In spite of this need, there currently is no cost-effective way of detecting V. cholerae easily in environmental samples. The most effective ways of detecting the pathogen are culturing environmental samples in selective enrichment media in the lab and real-time PCR, which require a lab, trained personnel, and enough time to grow cultures. Rapid detection systems such as immunomagnetic beads or DNA probe hybridization can be unspecific and are based on molecular techniques that can be expensive or difficult to use. Recent research in environmental cholera detection has focused on improving upon existing techniques, such as adapting immunochromatographic dipstick tests used for stool samples. Although there have been interesting synthetic biology projects aimed at preventing V. cholerae infection by meddling with the pathogen's quorum sensing mechanism, there have been no attempts to build an environmental cholera biosensor using synthetic biology to date. In light of this, our project aims to use synthetic biology to develop a V. cholerae sensor using a new technique. Instead of trying to detect the cholerae toxin, specific sequences of nucleic acid or antigen, we propose detecting V. cholerae autoinducer 1, the bacteria's species-specific quorum sensing molecule. If we rewire V. cholerae's own quorum sensing mechanism used in nature to gauge population levels and regulate pathogenicity in a harmless E. coli chases, we can build a cheap and easy-to-use biosensor that gives a color output when it senses the pathogen. This prototype can serve as a proof of concept for future quorum sensing-based pathogen biosensors. iGEM 2014. Support us. Thanks for watching.